What's up, Clash of Clan gamers? Mr. Cully coming at you with another video, and today we're going to introduce to you the mole. Am I talking about moles on the body? No. Am I talking about moles on the ground? No. I'm talking about moles in chemistry. And moles in chemistry is kind of a weird concept, but it is very, very important. So we actually celebrate in chemistry. There's something called a mole day where on October 23rd, we celebrate this thing called the mole. And you're like, what's that all about? I've heard about it. It's kind of like Pi Day. Maybe you've never heard about it before. But today we're going to talk about the mole and do some math with the mole. It's a very, very important part of chemistry. So the way I like to talk about the mole is kind of talking about what we can relate it to first. So the mole is a number. All right. It's a word. The word mole means a certain number, just as dozen means 12, just as a ton means 2,000, just as a score means 20, but you didn't know that. 4 score and 7 years ago, a score is 20. The word fortnight actually means something, if you didn't know that. Fortnight means 2 weeks. A jiffy actually means something. Just as there's 60 minutes in an hour and there's 60 seconds in a minute, there's 60 jiffies in a second. So when you say I'll be back in a jiffy, you're saying I'll be back in a 60th of a second. A light year actually means something too. It's how far light travels in a year. A light year is 5.88 trillion miles. It's pretty far. A buttload, Gibson gave me that one. I didn't come up with that. But a mole also means something. So just as all these mean something, it means a certain number, a mole means a number. Well, what number? A really big one. 6.02 times 10 to the 23rd. You're like, what? Who made this stuff up? I'm glad you asked. Not Austin Powers. I'm not showing that. This dude named Avogadro, look at him. Doesn't he look great? Yeah, look at that nose. So this dude named Amadeo Avogadro came up with this really, really big number, and it's named after him. So it's like, well, why even make a big number? Why even say that you have a mole of something? Like, who even has 6.02 times 10 to the 23rd of something? That's like 6 with like 23 zeros after it. I'm like, I know, okay? It's a really big number, but remember, we're talking about chemistry. In chemistry, what do we talk about? We talk about atoms. So you think about how small is an atom? Smaller than you realize. A piece of gum has a lot of atoms in it. How many? Pretty much that many, okay? So we deal with large quantities of atoms in chemistry that are really hard to quantify, okay? It's like I can't count how many atoms there are in something. It takes too long. I would never finish. So the reason that he came up with this number is for us to kind of talk about large quantities of atoms more easy. Kind of like how bakers, they don't say I made 3,000 cookies. They say I made 5 dozen cookies. All right. So it's easier for them to say. So chemists use this term called the mole, which actually means a number, for us to understand large quantities of atoms. All right. So that's what it means. It's a really big number. So, okay, let's combine this with our previous knowledge with the knowledge of chemistry. If you had a dozen carbon atoms, you'd have 12 carbon atoms. If you had a score of carbon atoms, you'd have 20 carbon atoms. If you had a mole of carbon atoms, you'd have 6.02 times 10 to the 23rd carbon atoms. So having a mole of something is just 6.02 times 10 to the 23rd of something. You can have a mole of anything. You can have a mole of avocados. 1 mole of avocados is 6.02 times 10 to the 23rd avocados. That's all that it means. So you can have a mole of anything. I can have a mole of moles on my body. That'd be really gross. But you can have a mole of anything. A mole is simply a number. Don't let it confuse you anything more than that. So when we talk about a mole in chemistry, we're talking about a mole. We're talking about how many atoms are in a specific substance. All right? So let's move on from this and let's kind of put it into a more of a visual. Can I see a mole of a substance? And the answer is yes. So how can I even comprehend what a mole of copper is? Well, a mole of copper is this little bar right here. It's a little bit bigger than a quarter. That is 6.02 times 10 to the 23rd atoms of copper. That's how much a mole of a substance is, and that's of copper. This little bar, that's iron. It's a little bit bigger. Okay, 1 mole of iron is 6.02 times 10 to the 23rd atoms of iron, again, and it looks that big. This over here, that's zinc. It's a little bit bigger, and this over here, that's aluminum. Now understand, having a mole of something doesn't mean they're going to be the same size. It just means that you have 6.02 times 10 to the 23rd atoms of that element or of that substance, whatever we're talking about, okay? So that's how big moles are. We can see moles of a substance. We can't see individual atoms. But you put 6.02 times 10 to the 23rd atoms together, it looks like that, and that's what represents 1 mole. So we can quantify moles. We can visualize moles. we can't visualize individual atoms, and that's why we use the mole. All right. So looking back to last unit, we worked with isotopes, and we use these numbers on the periodic table. There's a couple numbers that you're going to see on the periodic table in each element box. The first one at the top is going to be the number of protons. That's what makes it that element. So gold always has 79 protons. But down here, this is the mass. Okay, that's the mass of the element. That's the protons and the neutrons together, averaged out with all the isotopes, yada, yada, yada. That's what you get down here. So gold has this mass, 196.967. All right, and we learned that the unit for the mass of an atom is atomic mass units, AMU. We're going to be done using that unit from now on. Instead, this number is going to have new meaning to us. So let's say that we had 1 mole of gold. Okay, you're like, wait, what? If I had 6.02 times 10 to the 23rd atoms of gold, how much would that weigh? What would the mass be? And the answer is that number. Whatever this number is on the periodic table underneath that element, that is going to be the mass in grams of 1 mole of that substance. What do you mean? Well, I want you to visualize this even more. If I had 1 mole of gold, okay, and I put it on a scale, I'd have 6.02 times 10 to the 23rd atoms of gold. And that's going to have a mass of whatever that number is on the periodic table. Okay. So for gold, 1 mole is going to have a mass of 196.967, roughly 197 grams. But you look anywhere else on the periodic table. So if I wanted to know, okay, if I had a mole of carbon, then what? Then it'd have a mass of 12.0107. If I had a mole of silver, it'd be 107.8682 grams. So each element has a different mass, and therefore each element, if you had a mole of it, is going to have a different weight to it if you measured it on a scale. All right. So that's what a mole is. A mole is just an amount of something, and so this number on the periodic table can help us figure out the weight of something as well. So we're going to do a couple math problems here in a second. So here we have, and I'm going to go through all the problems that we're to see on our first worksheet. How many moles of gold atoms are in 500 grams of gold? All right, fair enough. This is going to be using dimensional analysis. This is why we learned dimensional analysis to start the year, is because we're going to use it throughout this year. Well, if you remember from dimensional analysis, what we do is we start with what we're trying to convert. In this case, I'm trying to convert 500 grams of gold. So that's what I'm going to start with, 500 grams of gold. All right. And what am I trying to convert that to? I'm trying to convert it to moles. I'm trying to figure out how many moles are in 500 grams of gold. Well, how can I figure that out? How can I convert between grams and moles of a substance? It's with this number that we just figured out, this 196.967. I'm going to round it to 197 because it's super close to it, and you're allowed to as well. Anytime you have a number down here that's really close to a whole number, I don't care. Just round it. So this number means 197, gold weighs 197 grams for every mole of gold that you have. For every 6.02 times 10 to the 23rd atoms of gold you have, it's going to represent 1 mole of that substance, and it's going to be 197 grams. All right. So I'm going to use this information, this number, and that's going to be my conversion. Okay. That's going to be in my conversion. What do you mean? Well, remember, in dimensional analysis, you need your units to cancel. So if I had 500 grams of gold up here, I'm going to have grams of gold down there. How many grams? Well, there's 197 grams for every 1 mole of gold. All right. So just like before, you cancel out your units. We're going Christmas colors here. And what you're left with is your answer in moles of gold. And now all that you have to do is the math. So in your calculator, what you're going to do is 500 divided by 197, and you get 2.54 moles of gold as your answer. Okay. Let's backtrack. Let's refresh. How many moles are in 500 grams of gold? You start with what you're trying to convert. You always write out what you're trying to convert. And you're trying to convert 500 grams of gold. Okay, boom, got that written down. Then you ask, okay, what am I trying to convert it to? I'm trying to convert it to moles. Well, how do I do that? I use this new number that we learned about, and that tells me how many grams of gold are in 1 mole of gold. So I'm going to put that into my conversion up here. And so 197 goes on the bottom and 1 mole goes up top. And you do the math and bada bang, bada boom, you got 2.54 moles of gold right there as your answer. All right. So that's one of the problems you're going to see is going from grams to moles. What about if you went backwards from moles to grams? So in this problem, you're asked how many grams of neon are in 2.5 moles of neon? Okay. Well, just like before, what you're going to do is you're going to convert moles. You're going to start with what you're given. And here I'm given 2.5 moles of neon. Don't like that. Don't like that either. Wasn't any better. All right. And so the question is, how do I get from moles to grams? I can use that same number that I used in the last problem for this problem. I look at the mass of neon, the average mass, which is 20.17. I'm going to round that to 20.2. Okay. Grams for every mole. So this number down here tells me that every mole of neon, every 1 mole of neon is going to give me a mass of 20.2 grams of neon. Okay. How is that helpful? Well, I can input that into my conversion here. So I'm going to put moles on the bottom. 1 mole of neon converts to 20.2 grams of neon based on what I just saw. So again, just like before, my moles of neon cancel, and what I'm left with is grams of neon in my answer, and all that's left for me to do is the math. So 2.5 times 20.2 gives you 50.5. So 50.5 grams of neon is my answer there. And so this was the same exact problem. We just had to work backwards. Instead of trying to find moles in this problem, we found grams. Okay, we start with moles and we went to grams. But again, we just use that number again, the molar mass, to tell us how many moles or how many grams of substance there are in each mole of that substance. So it's just a one-step dimensional analysis problem. Okay, so let's do this problem now. This one's asking something different. It's asking us how many atoms there are this time. Instead of grams, it's asking us how many atoms of iron are in 1.9 moles of iron. Okay, so it said nothing about grams. Let's recognize that. It said nothing about grams. It's asking how many atoms of iron are in 1.9 moles of iron. Well, what is a mole? A mole, 1 mole of iron is 6.02 times 10 to the 23rd atoms of iron. By definition, that's what a mole is. A mole of anything is 6.02 times 10 to the 23rd of that. So if I'm given the moles and I'm trying to find atoms, I can use this conversion to get me there. How so? Well, again, let's start with what we're given. The 1.9 moles of iron. And then you put in your parentheses. And from there, you're like, well, wait a minute. Do I use this number down here? And the answer is no. You don't, because what does that tell you? That tells you that there's 55.8 grams for every mole of that substance. Am I asked to find grams in this problem? I'm not. I don't need to use grams to find anything. In fact, I don't need this number at all for this problem. So you got to recognize, when do I need it, when do I not? I do not need that number for this problem. Instead, all that I need is this conversion up here. And yes, you do need to memorize what Avogadro's number is. 1 mole is 6.02 times 10 to the 23rd. So in this problem, all I'm going to put is down below 1 mole of iron is 6.02 times 10 to the 23rd atoms of iron. And that step alone gives me my answer because my moles of iron cancel, and what I'm left with is atoms of iron. You're good. So what I'm going to do is when you put this in your calculator, you got to be careful because the parentheses are super important. So you do the 1.9, and then you multiply that by 6.02 times 10, and then on your calculator there's a caret button, and that's for the exponent, times 10 to the 23rd, end parenthesis. So again, when you put this in your calculator, you got to recognize that this whole expression right here, Avogadro's number, has to be in parentheses. Otherwise, because of the rules of PEMDAS, when you're in math class, it gets all messed up, and then your answer is not going to be in the right expression. So once you do 1.9 times 6.02 times 10 to the 23rd, what you're left with and what answer you get is 1.14 times 10 to the 24th. And what did I just find? I found how many atoms there are, how many atoms of iron there are, and 1.9 moles of that substance. And that's a lot of atoms, but that's what you expect. Atoms are super tiny. So having a mole of a substance is a lot anyway. Having 1.9 moles of iron is even more than that. So your answer is going to be a big number when you're talking about the number of atoms. Don't be freaked out by that, okay? Atoms are super small. So anytime you quantify the amount of atoms that you have, it's going to be a big number. All right, what about this one? How many grams of potassium are in 2.4 times 10 to the 23rd atoms of potassium? Fair enough, okay? Well, this is asking something different than the other ones were too. It's asking grams, so I know I'm going to have to use this number down here. But where does it even talk about moles? It doesn't. It talks about grams and it talks about atoms. Well, here's the thing. Is there a conversion between grams of a substance and atoms of substance? The answer is no. But if you remember dimensional analysis, I could still find ways to get there. Well, what do you mean? Well, if I'm given atoms and I want to get to grams, but I don't have a direct conversion, is there another way? Well, yes. I can go from atoms, my amount of atoms, to moles, and I can go from moles to grams. So I can do atoms to moles, moles to grams, then I'm done. All right, so it's going to be two conversions. Well, how do I get there? All right, well, let's take it step by step. I'm going to start with what I'm given, as always. I'm given that I've got 2.4 times 10 to the 23rd atoms of potassium. And so what am I going to put on the top and the bottom? Well, if I had atoms on top up here, I'm going to have atoms on the bottom down here. And what am I going to convert the atoms to? Moles. So remember, 1 mole of anything is 6.02 times 10 to the 23rd of that thing. Okay, so 1 mole of iron is going to be 6.02 times 10 to the 23rd atoms. So on the bottom, I'll put 6.02 times 10 to the 23rd atoms of potassium is equivalent to 1 mole of potassium. 6.02 times 10 to the 23rd is 1 mole of something. All right. So now if I stopped here, my answer would be in moles. I don't want it to be in moles. I want it to be in grams. So this is where my atomic mass, my molar mass down here comes into play. This tells me that there's 39.1-ish grams in every mole of potassium. So in every 1 mole of potassium, I'll put this up here in my problem, it's going to have a mass of 39.1 grams of potassium. Okay, and I'll put moles on the bottom here because moles was on the top there. So let me cancel. My atoms of potassium cancel, my moles of potassium cancel. What I'm left with is my answer in grams, which is what I want. Okay, and again, this is a problem where you have to be careful when you put it in your calculator. The first number you have is 2.4 times 10 to the 23rd. Put that whole expression in parentheses. So in your calculator, I would put parenthesis 2.4 times 10 to the 23rd end parenthesis times 39.1 divided by, and then you got another big number again. So put this next number in parentheses divided by parenthesis 6.02 times 10 to the 23rd. And you should get, and make sure you check this along with me, 15.6. 15.6 or 15.58, but 15.6 rounded grams of potassium. If I asked you for an answer in grams and you got a super big number, that's bad, okay? Because you probably did it wrong. Grams, you're typically going to get a number that's between, a fraction of 1 and a couple hundred. You're not going to get something times 10 to the 20 something. So if you get a super big number that's in like scientific notation, chances are we're not asking for it, or you did something wrong because we're not going to have that many grams of something. All right. So that's how you do this problem is you have 2 steps now. If you're asked to go from atoms to grams, you have to have your intermediate conversion, which is moles. All right. One more problem, and then we're going to be done with this video. So now we're going the opposite direction. We're going from grams to atoms. The use of this is, let's say that I gave you a penny, and that penny was pure copper. I could give you this penny, and if you knew the right conversions, you could tell me how many atoms are in that penny. You're like, whoa, I can tell you how many atoms are in that penny? Yes. Using these conversions that we're learning, I could give you a substance. You could weigh it on a scale, find its mass in grams, and tell me, using conversions, how many atoms are in it. And that's actually what we're going to do in this class. So how do we start this? Well, we start this any other way we start a problem. You start with what you're given. 3.7 grams of copper. So let me write that down, 3.7 grams of copper. And I'm going to have some sort of conversion. Well, I'm trying to go from grams to atoms. And again, I don't have a direct conversion between grams and atoms. So I have to go from grams to moles and then moles to atoms. How do I do that? Well, how do I get from grams to moles of something? This thing, this number down here, tells me how many grams are in a mole of a substance. So copper has 63.5 grams in every mole of that substance. All right, I'm going to input that into my conversion up here. 63.5 grams of copper on the bottom to 1 mole of copper up top. So now my answer would be in moles if I stop there. But I need to go from moles to atoms. How do I do that? Avogadro's number. 1 mole of anything is 6.02 times 10 to the 23rd of that thing. In this case, it's going to be atoms. So 1 mole of an element, like copper, will be 6.02 times 10 to the 23rd atoms of that element. So 1 mole of copper on the bottom to 6.02 times 10 to the 23rd atoms of copper up top. And so using dimensional analysis, what cancels? My grams cancel, my moles cancel, and I'm left with atoms, which is exactly what I want. And so now I just need to do the math. So calculator, 3.7 times parenthesis 6.02 times 10 to the 23rd divided by 63.5. And that should get you 3.51 times 10 to the 22nd. Okay. And what did we just find? We found the atoms of copper. That's a lot, but again, we just found the amount of atoms. You expect to have a lot of atoms in something. So basically, if I were to give you a penny and you weighed it and it was 3.7 grams and it was pure copper, you just found out how many atoms are in that penny. Now, I don't think a penny weighs 3.7 grams. It might, I'm not sure. But that is essentially what you just found, was how many atoms are in 3.7 grams of copper. All right. So this is the fundamental use for moles, is quantifying large numbers of atoms, and then we can turn it into something that we can understand, such as grams of a substance. So this is the basis for what we're doing. Okay. If you have questions, let me know. But these are the main problems that you're going to be seeing over the next couple weeks.